In this problem, we want to look at what happens if we start with a vapor-liquid mixture of water and we heat it in a closed container so the volume is fixed. And we'll look at two conditions. Either we start with 15 grams of water or 3 grams of water. Initially, the container is evacuated, then we add these at 25 degrees C. Now I'm going to use steam tables, and the steam tables are on the LearnChemE site, a spreadsheet, steam tables, to do the calculations. So let me show you the calculations, and I'll show you how I got these values. So the table on the left is when we add 15 grams, and so 150 milliliters divided by 15 grams and convert it to cubic meters per kilogram gives us a specific volume of 0.01. And so what I've calculated at various temperatures, as we've added heat to the system, is the quality at that temperature. And so let me show you how that's done with the spreadsheet. So at 150 degrees, it's the quality, and the pressure here, of course, is the saturation pressure at 150 degrees. And so if I go to the steam table, put in 150 degrees, now for these steam tables, it'll do the calculations of quality. If I put in a quality, and so I have to trial and error, but it doesn't take very much, to get a specific volume of 0.01. So, this accuracy is more than sufficient for what we're trying to do. So the quality 0.023, that's the value then in the table. I did this at these various temperatures for these two specific volumes. So this smaller specific volume is when we add only 3 grams. And so what you see happening, if we look on the left, the quality increases. We have more vapor as we raise the temperature and less liquid. Of course, the vapor is denser at the higher pressure until we get to the temperature and pressure where we have all vapor. And so any higher temperature, we just have all vapor. In contrast, if we look at the case where we start with a smaller amount, of course, we therefore have a much lower quality, and we now raise the temperature. The quality increases and increases until we get to temperature. Now the quality starts decreasing. We have a smaller fraction in the vapor phase. Quality decreases until we have all liquid. So completely different behaviors. One case we raise the temperature, we have all vapor. Another all liquid. Let's look at the reason why this is. So here's a log pressure versus log volume plot for water. In our first condition, 15 grams was added in specific volume 0.01 cubic meters per kilogram. As we raise the temperature and pressure by adding heat, you can see we're crossing quality lines, larger and larger values, until we get to this point where now we have saturated vapor, and then above that would be superheated vapor. In contrast, when we start with only 3 grams, so 0.002 cubic meters per kilogram. This specific volume is below the critical specific volume. And so therefore, as we raise the temperature, first we increase the quality, is indicated by lines we're crossing, but then it starts going in the other direction because the curve in these lines eventually have to hit the critical point. We just lose that resolution in this kind of plot. We cross the saturated liquid line now, and we have just liquid above this at higher pressures. And so it's where we are relative to the critical volume as to whether we end up with all liquid or all vapor as we heat a liquid vapor mixture in a closed container.